Hello everyone, welcome to the next lecture on the PY question series. Today I will explain you how you can find the solutions related to the root finding problems. I have taken the CSIR net and the gate mathematics of these years. Myself Dr. Harish Garg. You can follow my YouTube channel where you can find the playlist of the CSIR net and you can see the various lectures topic wise as well as the subject wise is available in this playlist. All these lectures are explained with the help of the shortcut tricks. If you watch my all these lectures in this available in this playlist, you can crack your CSIR net, GATE, NBHM, any of the examinations in a very simple manner. Don't forget to subscribe my YouTube channel. As I told you, my objective of this lecture is how you can solve the root finding problem from these two examinations. What is the content behind this? We will see how you can solve the problems related to the iterative methods, Newton's order of convergence and rate of the convergence. Make sure you have to watch this video till the end so that you can get how you can solve each problem in a 15-second time period. Now let me quickly recall you the concepts. First of all, your first target is to always find the fixed point. What is the definition of the fixed point is if phi of x is equal to x. For example, how you can find the fixed point of this? There are so many methods. You can draw the graphically. Otherwise, you can simply take this function to be x. Fine. And then you can find the value of the x from this equation. So clearly say this is the quadratic equation. Minus of 2 is 0. If you solve them, you will get as 2 and minus 1. Therefore, 2 and minus 1 are my fixed point of this equation. Fine. Similarly, if you find this, if you solve them, so clearly say 1 is equal to 0, which is not possible. It means there is no fixed point of this function. So always remember your first point is you have to find the fixed point. Then once you can find the fixed point, then the iterative equations will converge. Then the iterative equation will converge to the fixed point. Fine. If you are able to find the fixed point, then the iterative equation will converge to fixed point for any choice of the initial value x naught. Remember, if your iterative method convergent, then it will be convergent to the fixed point and for any choice of the x naught. But the question arises is how you can define this value of the fx. There are so many ways that you can define that. For example, if I simply take this function, can you find the value of the x? How you can find the value of x? I can find the value of x by using this way. Find this is the first method. Or you can find the value of the x from this. It will be my root of 2 minus x cube. Or I can find the value of the x from the first two. I can take x as a common. Then it will be x square plus 1 minus of 2 0. Then x will be my 2 over x square plus 1. Or you can also find I can take x square as a common. This is x square plus x. If I take x square as a common, then it will be 1 plus x minus of 2 0. Then x will be my 2 over 1 plus x. And many more methods are there. So you can see there are so many methods you can find the value of. So this is my phi x. I can compare them. But the question arises is which one is the suitable one? Which one is the suitable one and which one will give you the convergence of this iterative method? The rule is whatever the value of the phi x you have found, it is convergent if phi x, absolute value of the phi dash x is less than 1. If phi dash x is my greater than 1, then the iterative process is divergent. If phi dash x is strictly less than 1 and phi dash x is equal to 1, then the equation would be very large, but it is also the convergent. So definitely we always need a phi dash x to be very small so that the convergence will be easier and take a less time. So whenever you have the fixed point iteration, if this condition satisfied, then it means the iteration method will converges to the fixed point. Whatever the fixed point you have taken converges to a fixed point for any choice of the initial value x naught. And once you know the iteration method converges, then you can find the error bound by using this equation where lambda is the maximum value of its derivative. If you are new to my YouTube video, you can like and subscribe my YouTube channel, and you can subscribe and you can comment on this video. The last concept, that is the order of convergence. So whenever you start with this equation, this P is called as the order of convergence. If you like my these videos, if all of you will like my this video, then I will put my next video also on the numerical analysis and some other topics in a very simple manner. If you are new to my YouTube channel, you can scan and join my WhatsApp group for the various discussions. So let's start with these questions. Remember, I will explain you each question with the help of the 15-second time period. Don't forget to like my video. So if you really want that I can put my next video, you have to like this video. Now read the statement very carefully. Fx, which is equal to ax plus b, where a and b are my real numbers, and the iteration method is given to be this. Look at that. Options, from the option, b does not play any role, and b is my real numbers, so I can choose b is my 0, because from the option b doesn't play any role. So therefore my fx will be ax. Clear? Now the iteration method convergence. What is the rule for the iteration method convergent? That means phi dash x is less than 1. I can substitute this value. So that means mod of a is less than 1. So what does it means? Because mod of a is less than 1, it means minus 1 to plus 1. He said for all, for no value cross, only for a0 wrong, that is lies between them is the correct answer of this problem. Look at the second one. Fx is given to be ax plus 100, where a is a real number. Then the iteration method convergent. Again, when the iteration method convergent, when this number should be less than 1, that means mod of a is less than 1. So clearly say 5 is not less than 1, 1 strictly less than 1, 1 is not strictly less than 1. This is fine, this is wrong. So again the answer is C is my correct answer. Again I said you don't forget to like and comment on this video. Now look at that. The value of the alpha and beta such that this equation has third order convergence to root a. Look at the option. The answer is not dependent on the a. So I can choose a is my 1. Fine. Then what will be your xn plus 1? Xn plus 1 will be 3 alpha xn minus alpha x cube plus beta times xn plus beta over xn. Now what is the meaning of the third order of the convergent? That means limit n approaches infinity, xn plus 1 minus the convergent. If the limit is my this, if a is my 1, x will be my 1, divided by xn minus 1 raised to power 3, it is my fine. Or instead of the x approaches, I can simply take x approaches the limit. What are the limit is 1 of x minus 1 and x minus 1. This is my xn plus 1. So now you can see whether the limit is finite or not. I can substitute this value, 3 alpha x minus alpha x cube plus beta times x plus beta over x minus 1 divided by x minus 1 cube. Now you can take the limit x approaches 1. Now it has a third order convergence, so what it means, the limit should be finite. So if I substitute this value, it is a 3 alpha minus alpha plus beta minus 1 over, it is a 0. Fine. Now but we need a limit is a finite, so definitely the numerator value must be 0. That means 2 alpha plus 2 beta must be 1. Fine. Now look at the option. You can see that, or that means you can see alpha plus beta should be half. So this number will be 1, not equal to 2. It's a 4 by 8 half, 4 by 8 half, 4 by 8 half. Fine. So the last option will be cancelled out. Now it's a 0 by 0. Then I can apply the L'Hopital rule. So if I apply the L'Hopital rule, it's a 3 alpha minus 3 alpha x square plus beta minus beta over x square divided by 3 times x minus 1. Again the limit is a finite. So if I take x is equal to 1, if denominator is a 0, numerator is 3 alpha minus 3 alpha, again a 0. So again I can apply the L'Hopital rule. So this is minus 6 alpha x minus plus 2 beta over x cube divided by 6 times x minus 1. So if I take again it's a finite number. So that means minus 6 alpha plus 2 beta should be 0. Otherwise the limit will be infinite. So that means beta should be 3 times alpha. So clearly say this option will be cancelled. Beta is a 3 times alpha. Beta is not a 3 times alpha. So the right answer is B is my correct answer. Okay, the iterative method xn of this solution converges quadratically. That means limit x approaches xn minus x minus quadratically. This should be the finite. What is the limit is? Converges to the 2. X approaches 2. That is your target. Fine. Now look at the first part. If my gx, that means xn plus 1 is x square. So if I look at the first option, then this will be x square minus 2 divided by x minus 2 whole square. So it will be x square minus 4. So x minus 2 x plus 2 divided by x minus 2 square. That will be x plus 2 x minus 2 as limit x approaches 2, which is a infinity, but we need a finite answer. This option is cancelled. Look at the second option. Limit x approaches 2. If I take xn plus 1 is this number, then it is x minus 2 square minus 6 minus 2 is a minus 8 divided by x minus 2 whole square. So it will be 1 minus 8 over x minus 2. So clearly say it will goes to the infinity as x approaches 2. This option is also cancelled. Look at the third option. Limit x approaches 2. 1 plus 2 over x minus 2 divided by x minus 2 square. So that will be minus 1. If I take the LCM, it will be this number. Fine. So it is my modulus value. I can cancel out. It will be 1 over x into x minus 2. Again it will goes to the infinity. So the right answer is my last is my correct answer. And if you want to calculate it, let me calculate the last option for you. So what is the fourth option is? Limit x approaches 2, that means x square plus 2 over 2x minus 1 is absolute value divided by x minus 2 square. So if you take the LCM, it is x square minus 4x plus 4 divided by x minus 2 square. So clearly say this limit is a 1, which is my finite number. So the right answer is D is my right answer. Always remember, whenever it is given to be convergence quadratically, convergence third order, always apply this definition. Okay, again your target is to find the rate of convergence. So that means your target is to find the limit xn plus 1, xi is the solution, divided by xn minus xi raised to power p, as so your target is to find the value of this p. Fine, very simple. Again let's start with the first option. If p is equal to 1, if I substitute xi, so it's a 10 minus x4 plus 3x square minus xi divided by x minus xi. If I take p is equal to 1, now look at the numerator. Since xi is the solution, that means xi raised to power 4 minus 3 xi square plus xi minus 10 is equal to 0. That means this, when you substitute x is equal to xi, the numerator becomes a 0. It is my 0 by 0 form. That means, what is that? Is it a finite? It is not a finite number. Fine. You can see, firstly I can solve for you. So it's a 0 by 0 form. Fine. So you can apply the L'Hopital rule. So minus 4x cube plus 6x square divided by 1. So if you substitute xi, definitely it will give you the finite answer. So when I take p is equal to 1 is the correct answer. If I take p is equal to 2, then it will be my 2. Fine. Then the numerator is still the same, 6x square divided by, if I take 2, then it will be x minus xi. So clearly say it will goes to the infinity, because as x approaches in, so that means 2 is not the rate of convergence. So if 2 is not the rate of convergence, higher order will not be there. So the right answer is A is my correct answer. Okay, consider the iteration functions. This is the Newton method, an application to find the square root of 2. Fine. Then starting with the first, okay, your target is to find this x1 and x2. So x0 is my 2. So what is the x1? If I sub, okay, what is my function is x is equal to root 2. That means I can take the function is x square minus 2. So my function will be, so I can find the equation xn plus 1 xn minus fx divided by 2x. So if I take the LCM, 2x is the LCM, x square plus 2, I can take half x plus 2 over x. Now when x0 will be 2, what is my x1? If I substitute the value, so 2 plus 1, 1.5. x1 is 1.5. It's the open interval. The first option will be cancel out. x1 is the equality. Yes, B is the correct answer. x1 1.5, x1 equality also there. Now what is the x2? So 1.5 plus 2 over 1.5, so 2 and 4. So I can take the LCM, 6, 12 is the LCM, 9 plus 8, 9 plus 8 is 17. So if I divide 1, 4, 1. So 1.41 something. So x2 is less than 1, wrong. x2 is less than 1.5, correct. B and C are my right answer of this problem. Okay, consider the function fx. Let x equal to gx, so that any fixed point of the gx is the solution of the 1. Okay, you have to find the fixed point, but there is no need. Let me check the option. Gx, first option, gx will be this m. Okay, a is the positive constant, so I can choose a is my positive constant as a 1. Then m belongs to -1 to +1, but clearly say if I take m is 0, then g of x will be infinity. Then it is not a, it's not a fixed point. So the first option will be cancelled. Second option, now your target is to find the fixed point. Can you find the value of the x from this equation? So x will be x square minus 2. So yes, this is my gx. Another way, you can also find the value of the x. I can take x common, so x minus 1 is equal to 2. Fine. Or any other way, okay, I can find the x. Clearly say this 1 plus 2x is formulation of this. Otherwise you can start from this 1 plus 2x is equal to x. If you start them, it is a x plus 2 is equal to x square, which is the same equation of this. So yes, these are the possible choices. As I told you in the initial, there are so many choices, so one of them will be this point. Okay, look at the third option. K is any possible number. So k, okay, k is a non-zero and it can be any possible number. Yes, that's true, because if you take any of the k, this numerator, this value will be 0. So g of x will be x. That's a fixed point. That's true. G of x is x square minus 2, correct. 1 plus 2x are the only. These are said only, but not, because I can found this is also the fixed point equation of, this is also the possible value of the gx, but he said only. So that option is cancelled. B and C are my correct answers. Don't forget to like and comment on my video. I will upload the next video if I found that good enough number of the like on my this video. F is the mapping from 0, 1 to itself. Fine. Xn plus 1 is given to be f of xn. Which of the following will yield a fixed point? What is the definition of fixed point? I can substitute. First point, I can take x is equal to x square by 4. What are the values of the x? So clearly say x will be 0, x will be 4, and this 4 will be lies outside the domain, and yes, 0 is my fixed point. Correct option. Look at the second point. I can take x is equal to x is x square by 8. The fixed points are my 0 and 8. This point lies outside, but still this belongs to this closed interval. Yes, this is also the point. Similarly for the third case, fixed points are my 0 and 16. Yes, 0 is also there. 0 and 32, that is also the point of interval, fixed points. So all are my correct answers. There is one more method. So what is the fixed point? When you can say the fixed point? When this condition hold. Fine. So look at the first case. 2x over 4. X belongs to the 0, 1. So what is the value of this? So clearly say it is 2 over 4. Why? Because x value is less than 1. So that's a less than of 1. So again the first option is correct. What is the second option is? If you take the derivative, it is a 2x over 8. It is x over 4. So clearly say this is less than of 1 over 4. This option is also correct. If you look about the third option, then it is a x over 8, which is again less than of the 1 over 8, and it is a 1 over 16. Yes, it is again less than of 1. So all the options are my correct answers. Okay, f of u is u cube minus u minus 1. Fine. So I can write here is u cube minus u minus 1. Starting with the initial guess, the fixed point equates converges. The fixed point is my this. What is the g of u? U cube minus 1. When it will be convergent? When this condition hold. Fine. Now what is the g dash of u? 3u square. Initial value is 1.5. So 1.5 square. Clearly say which is not less than 1. So first option is cancelled. Look at the second option. Starting with the initial guess again, the fixed point of g. Now in this case, g is my 1 plus u cube. So can you find the g dash? It is 1 over 2, 1 plus u cube into 3 times u square. Add the point of 1.5. So it is 3, 1.5 square divided by 1.5 cube. So clearly say it is my 3 by 2 degree, upper degree is greater than of the denominator. So clearly say this is not be less than 1. So this option is also cancelled out. U star is the root of the equation and u is my greater than. Okay, so let me clear this one. Okay, u star is the root of the equation, so that means this is my 0. Fine. I can write this equation is fine. So if I look at the graphically, what is the u cube? We know that this is the graph of the x cube, and now it's x cube minus 1. So it will graph will start from this one. This is the graph of u cube minus 1, and I can draw the graph of the x is equal to 1. Fine. Now this is my fixed point. Fine. Also we call as the solution of this equation. So this value is my greater than 1. Fine. So I can take an as say 1.5. Then u star is the stable fixed point of this equation. Now u star, what is the point of this point? Oh, sorry, firstly what is this point? So clearly say this point will be, can you find the root this point? How you can find this point? This point will be, it is my 1, because it axis on the cut axis, it's a 1. So this point will be my greater than of 1. Now alpha star or you can say the u star will be lies here. U star will be the any point which is greater than of 1. So I can consider this point. What is the fixed point of this? Now you can see the graph of x u cube plus minus 1 here, y is equal to x this. Can u and u cube minus 1 intersect each other at u star which is greater than 1? Any u star which is greater than of 1, can these two points intersect? No, these points are not intersect, so it means they are not a stable point. So the right answer is my D is my correct answer. How you can check about the last option? That's again a very simple. Root lies between them. I can apply the, or you can see that this is the root. It's a 1. Definitely it lies between 1 and 2. Otherwise we can use the intermediate value theorem. What is the f of 1? 1 minus 1 is a negative. What is the f of 2? 8 minus 2 minus 1, which is a positive. So definitely one root must lies between 1 and 2. Don't forget to like my video, and you can subscribe and comment on it also. Consider the function this equation limit. What does the limit means? Limit means fixed point. There is no need to solve them, you just find the fixed point. That means 2 plus x is equal to x. Fine. Now you can check about the options. Say firstly 1. Is it true? No. First option, D option is cancelled. 2 plus 4, which is 2. This is a plus minus 2 is equal to 2, because x1 is x0 is a positive, so this must be the positive. So yes, this is a correct option. Minus 1, if you take as a minus 1, it is a 1, it is a minus 1, but it is plus minus 1 and minus 1, but x0 is my positive. So if x0 is my positive, then this limit must be positive. Fine. So that means, but we need a minus 1. This option is cancelled. You can see this part is I can write this part is again 2 plus x, which is obviously the limit of this equation. This is the first method. You can start from the option. Otherwise you can find the limit of this. You can find the value of x. 2 plus x is x square, or you can say x square minus x minus of 2 0. So x will be my 2 and minus 1, but because x0 is my positive, so the limit will convergence to the positive limit point. So that means x converges to the positive limit point. That's a 2 is the only right. If say x0 will be my minus 3, then it converges to the negative limit. Okay, look at this another one. Consider the equation this. Okay, now again the rate of convergence. So my target is to find the limit. X approaches, converges to the root 2, xn plus 1 minus root 2 divided by xn minus root 2. Firstly, for the first option, I will check about the convergence 1. Now I can substitute the value of t. Xn plus 1, that is this number, half x plus 2 over x minus root 2 divided by x minus root 2. So what is that limit? If you take limit as a root 2, so this number will be half root 2 plus root 2 minus root 2, that's a 0, and you can see it's a 0 by 0 form. I can apply the L'Hopital rule. If I apply the L'Hopital rule, it is a half 1 minus 2 over x square over 1. So clearly say if you take the limit as root 2, it is 1 minus 1 0, which is my finite number. Fine. So once this is my finite number, what does it mean? 1 minus 2 over x square 1 minus 1 0. Yes, it's a finite number. Once is a finite number, that means the rate of convergence is 1 is the correct option. Look at the second option. The rate of convergence is 2. That means it will be my 2. It will be my 2. Then it will be my half x plus 2 over x minus root 2 divided by x minus root 2 square. Fine. Now again it's a 0 by 0 form. I can apply this 2 2 by x square over 2 times x minus root x. Now what can you say? Again it's a 0 by 0 form, so again I can apply the L'Hopital rule. So it will be my 4 over x cube into 1 over 2 over 2, which is also the finite number as limit x approaches root 2. So where is the mistake? How you can say it is not be the fixed point? Now you can see both are the right answers, but by the definition the rate of convergence is the largest order, that's the largest p which satisfies this condition. So since the largest p is satisfied as a 2, therefore the A option is the false answer. Now look at this. Your basic target is to find the limit of this if it is a finite for the value of the p. Fine. Now look at the third option, the iterative scheme for the fixed point. What is the iterative scheme for the fixed point? Is xn plus 1 is fx, and fx is given to be x square minus 2. That means xn plus 1 is xn square minus 2. Clearly say which is not similar to this one, so that option is cancelled out. The iterative method for this, what is the iterative scheme for the Newton-Raphson method? That is a f upon f dash. So I can substitute xn, it's a x square minus 2 over 2x. So clearly say it's a 2x square minus x square plus 2 over 2x. That means yes, this is the right answer. So B and D are my correct options. Okay, look at this another one. Let f be the smooth function with a non-vanishing derivative. Newton method for finding the roots is same as of this method. I think very simple, clear statement is clear. That means you can start from the first option, check whether you can derive the Newton's Raphson formula for this or not. That's the question. Fine. So look at that. What is that? First is the fixed point. What is the fixed point? Is fx. Okay, in this case it is my gx instead of the fx. In this case this is my gx. So what is the value of the gx? G of xn minus f of xn divided by this, and clearly say this is my Newton method. So it means yes, this is the right answer. Look at the second option, forward Euler method. What is the forward Euler method? Is yn plus 1 is yn plus h times slope xn. Remember that the Newton forward Euler method is dy over dx, which is f of x comma y, that is basically the slope. Fine. Now unit step length, h is my 1, so I can substitute this value. H is my 1. What is the f? F is my dy over dx. That is can I find the value of dy over dx? It's a fy over f dash. So clearly say yn minus f over f dash, which is the same of this part. Yes, B is also the correct answer. Now look at the third option, the fixed point equation for this. That means xn plus 1 is x plus fx, which is not same, so that option is cancelled out. Fixed point equation for this fourth option, that is x minus fx, which is not the same as of the Newton's method. So the right answers are A and B are the correct options. Okay, the equation this again, which of the following, first case is the equation method. So xn plus 1 is fx, x square minus 2, clearly say which is not similar. Newton's method, so xn plus 1 is x minus fx divided by derivative. So if you take the LCM, x square minus x plus 2 over x. So yes, this is the correct option. Third option, fixed point, that is xn plus 1 is x square plus 2 over 2x. So clearly say I can take 2 as a common, x plus 2 over x, which is the same of this. Newton's method for x square plus 2, xn plus 1 is xn minus fx divided by its derivative. So clearly say if I take half as a common, x square is x is LCM, then x square minus 2. So clearly say which is not correct because it's a negative of the 2, but we need a positive 2. So this option is cancelled. B and C are the right. You can see within the 10 to 15 seconds you can solve this each problem. You can comment, you can share this lecture to your friends as well. Again the equation is there, possible limits. What is the meaning of the limits? You have to find the fixed point. Fine. You have to find the fixed point. Look at the option. Firstly, x naught is my 0. Fine. So I can scaling them, x square minus 3 0. Can you factor them? Or you can check about there is no need to solve them. Check about the first option, minus 1. It is 2, which is minus 1, not satisfied. Because it means minus 1 is not the fixed point. Is the 3 fixed point? Check 3 plus 3, 6, which is 3. Again not equal, so 3 is not the fixed point, so it is not the limit. 0 plus 3 is equal to 0, not satisfied. 0 is not the fixed point, it is not satisfied. So yes, this is the, because I can consider it is infinite time, I can consider this is again as a x. So root of 3 plus x is similar of, so D is my right answer. Okay, look at this another one. F is a twice differentiable and continuous function with a unique fixed point. Unique fixed point is x. So x is my unique fixed point of fx. It is given to you. Then for any x which is a positive, fine, the equation, okay, xn plus 1 is f of xn. That's the equation formula is given to you. L is my maximum of this. I think you easily understand. It's a very simple. Look at the first option. If L is 1, that means f dash is my 1. So what does it mean? If f dash is 1, it means the equation method convergent, and if it is convergent, then it converges to the fixed point. What is the fixed point given to you? X. So that means this xn will converges to the limit point of, so because this condition hold, xn converges to x provided L greater than 1, that's greater than equal to 1. That's strong because we need a strictly less than 1 for the convergent. The error en. Okay, now look at the error. So I can start from the left hand side, en plus 1, so absolute value, fine, that is xn plus 1 minus x. What is xn plus 1? F of xn. X is my fixed point, so I can say it's a f of x. Now f is a twice differentiable function, then I can use the Lagrange mean value theorem, fine. So I can return this function is f dash of some xi into xn minus x, fine. Now what is the f dash x? It is a less than 1, so it is less than of xn minus x, and I call as a L, fine. Xn minus x is again e, so yes, this property satisfied. Clear? Now look at the fourth option. I can rub this part, and fourth option said if f dash x is my 0, that means L is my 0. No, it is not necessary L is 0 because L is a maximum, but we need f dash x is my 0. Okay, then again you have to find the error, fine, en plus 1, that means up to this point is okay, up to this point is okay. Then because f dash x is 0, then LMV theorem is not applicable. Then we can apply the Taylor series, fine. So it will be f dash, say xi, xn minus x plus f double dash xi over 2 factorial xn minus x whole square plus so on. Now this value will be 0. F double dash x is a positive number because it's a twice. F is a function from the 0 1 to 0 1, so this number is my positive. I call as a C, fine. this number is my en square. Because it's a modulus value, I can say this is a less than or equal to C, E and square. So the right answers are A, C and D are my correct answers. Okay, consider the function x square plus ax plus b is equal to 0 and it has the two real roots. What does it mean? Sum of the root is my minus a, product of the root will be my b. Then which of the following iteration scheme convergent? So it will be my xn plus 1 is gx or phi x. When it will be convergent? When g dash x should be less than 1. Fine. So now let's start with this concept. What is the derivative of this? So firstly I can write the g as minus a plus b over x. Then what is my g dash? Minus b over minus minus plus. Now if I take the modulus value, this should be less than 1. That means b and it converges to the alpha. That means I have to substitute x is my alpha. Fine. Now I need a alpha and beta. I can substitute the value of b. b is my alpha beta, which is less than of alpha square. What does it mean? This number is, so that is a correct option. Similarly, look at the second option. Then your target is to find the g dash. What is the g dash? Is minus 2x over a. So what is the g dash at the point alpha? It is 2 alpha a. It must be less than 1. That means 2 alpha must be less than a. A I can substitute as alpha plus beta, but he said alpha is greater than 1. It is not always true. Look at the third one. What is the g dash? It's a minus minus plus b over x plus a whole square. Then I can start with the g dash at the point alpha. It is b over alpha plus a square. It is less than 1, or b is less than, what is alpha plus a? You can see alpha plus a will be minus beta square. So what is the value of the b? b is my alpha beta. It is less than of beta square. So clearly say alpha should be less than beta. Satisfied. Look at the last option. Last option is similar to the second option, and I already obtained that 2 alpha is less than of this option. So correct options are A, C and D are the right answers. Okay, look at this another one. Consider the alpha which is lies between 0 and 1. So I can choose alpha is my half, so that my calculation will be easier. Consider the iterative scheme. Xn plus 1 is xk square plus half. The above has the two fixed point, xi1 and xi2 are my fixed point. That means these are the solution of this problem. I can say this number is, I can take the LCM x square minus 2x square minus 4x plus 1 is equal to 0, and xi1 and xi2 are the roots of this equation. So once they are the root, then what is the sum of the root? 2. What is the product of the root is c over a. This is given to you. Then xi1 is lies between this condition. Then which of the following iteration? Clearly say, firstly we can see xn plus 1 is this. So this is my gx. Firstly I can check about the convergence. What is the g dash of x? Half will be cancelled out, this number. Fine. Then what is the range of the xn? It is not given to you. Now then for this given sequence has the two fixed point. So if this number is less than 1, what does it implies? If this happens, then the method will converges to the xi1 or xi2 to the, because these are my fixed points, for any choice of initial value. Fine. Now for which value of the xi they have chosen, either the 1 or 2. So clearly say we need a value of the xi which is less than 1. So it will converge to the fixed point xi 1. Fine. Now what does it mean? That means xk will converge to the xi 1 for any choice of the x0. Fine. That means the limit of xk as k approaches infinity will be my xi 1 for all the choice of x0, and you can see limit x0 is converges to xi 1 for any choice of the x0. Limit will converge to the x1 for any choice of the x0. So both are the correct options. Now look at this first and the third option. Now look at the first option. Again the sequence is given to you. I can find the value of the x1 xi1 plus half xk square minus xi1 square. Again this is my gx. For the convergence I have to find this derivative to be 1 0. So it is less than 1 converges to the xi1 because xi1 is less than 1. It is given to you. Yes, this is equivalent to this statement. Look at the second option. xk1 is xi1 plus half. If I open this bracket, xi plus xi2 minus xi1 of x minus xi1 xi2. Then what is the derivative? 0. xk plus half xi2 minus xi1. Clear? Now clearly say what is the xi2 minus xi1? If I take xi2 minus xi1 square, it will be 4 minus 4 times of this, it will be 2. So this number will be my root 2. So clearly say if this xik will converge to xi1, it is less than 1. So definitely it is not be less than of 1, because if I say xi1 is say my 0.7, then it is greater than 1. So it is not convergent, it is not equivalent. Okay, now look at the June 2023. How many real roots has this equation? How many real roots I can say as a G? Which things come in your mind when you think about the real roots? By using the discard rule of sign. Fine. So if I consider this is my fx, how many positive roots are there? There is a change in the one sign. So it means at most one positive root. They are talking about the real root, that means positive and negative both. Now what is the f of minus x? Minus x cube minus 3x minus 2023. So what does it implies? There is no negative root. Fine. So how many roots, maximum roots are there? Because it's a cubic equation, so that means complex roots are my 2. Clear? All are not because it has a 3 degree, so it has the 3 roots maximum, and out of them all of the 3 are not complex number, because complex number always in the pair. Fine. So that means complex root can never be 3. There is no negative root, that means there is a 1 positive roots and the 2 complex roots. And how many real roots? 1 is the positive real roots. I hope you can like and subscribe my YouTube channel. Now we will discuss all those questions which was appear in the GATE examination. So let's start with the GATE 1996. Y1 is my sum sequence approximating the, no, this is not the question, this is there. The equation e raised to power x minus 4x square has the roots lies between this. The fixed point equation xn plus 1 is half e raised to power x by 2, convergent, divergent. So that's again simple. Let's say the derivative of this e raised to power x by 2. Now x lies between, root lies between 4 and 5. Choose any number, say 4.5. What is the value of this? E raised to power 2. Clearly say this number is my greater than 1. That means this is divergent sequence. So first option are cancelled. Okay, Now your again target is to check the convergence. So limit, again answer is not dependent on the a, so I can choose a is my 1. If a is 1, x approaches 1. xn plus 1 minus 1 divided by x minus 1 raised to power p. We have to find for which case it will be the fine. So let's start with the first case. Limit x approaches 1, x over 2, a is my 1. If I open this bracket, it will be 1 over 2x minus 1 divided by x minus, firstly I can choose as a linear, that means if I choose p is my 1, or in general I can take it as a p. If you take x equal to 1, it's a 0 by 0 form, so then I can apply the L'Hopital rule. So it will be x raised to power 1 half minus 1 over 2x square divided by p x minus 1 of p minus 1. Clear? So clearly say again, if you take x equal to 1, it's a 0 by 0 form. Again I can apply the L'Hopital rule. So it is my 2 upon 2x cube divided by p into p minus 1 x minus 1 into p minus 2. So clearly say, now if you take x is equal to 1, it will be infinity if p minus 2 is my non-zero. Fine. If p minus 2 is my non-zero, then it will goes to the infinity. So that means when it will be the finite, it goes to the finite when p minus 2 will be 0. So once p minus 2 will be 0, what does it mean? P is equal to 2. P is equal to 2 means that is my quadratic convergent is the right answer. Again you can see, when you take p as a 1, again you will get a finite answer. Fine. When you take p is equal to 1, finite answer. P is equal to 2, also as a finite answer. And since the order of convergence is the highest power p, so highest power p for the convergence is my 2. So that's why quadratic is the right answer. Okay, the iterative scheme. Again, this is the iterative scheme. xn plus 1 is equal to g of x will converge or not. So which point it will be converged? It will converge to the fixed point. Fine. So how you can find the fixed point? Xn will be 1 over 5. Again there are the two methods. Firstly I can start from the options, or otherwise we can find the limit. So firstly start with the options. 1.6. Check whether the 1.6 will satisfy on both the cases. 16 minus 1.6. Fine. So it will be 10, 4, 4, 4, 30. 16 minus 15 by 2, 7.5 into 1 over 5 is 1.6. So clearly say 8 is not equal to 16 minus. So first option is cancelled because this is not the fixed point. Similarly 1.8. 1.8 is 1 over 5. 16 minus over 1.8 into 0. So clearly say 9. It is 18 into 16 minus 120. Clearly say which is not equal to 9. So this option is also cancelled. Check about the 2. 2 is 1 over 5. 16 minus 6. So 10, 2, which is satisfied. So yes, it is a convergent and it converges to the point 2. Fine. Because whenever the iterative scheme converges, it converges to the fixed point, and fixed point is always by limit point. Second method is, instead of this I can find the limit point. How you can find the limit point? I can solve this equation. So it will be my 5x square minus 16x plus 12 is 0. 5x square minus 10x minus 6x plus 12 is 0. So 5x minus 6 and x minus 2 is 0. So x is my 2 and 6 over 5. So 6 over 5, that's a 1.2, which is not available in the options. That's why 2 is available. So 2 is the right. Otherwise 6.5 is also the correct option of this problem. Okay, the iterative scheme. Again, xn plus 1 is my g of x, is the nth root of the positive number, that is x of n minus of a is my 0. Fine. Again the answer is not given on the a. I can choose a is my 1. Clear? Then your iteration scheme will be half xk plus 1 over x raised to power n minus 1. Then for what value of the n the iterative scheme will fail to converge, that means diverge. Fine, very simple. I can choose the option. If n is equal to 1, what is my iteration scheme? Xn plus 1 is half n minus 1 0, this number. Fine, so that means what is the meaning of that? This is a divergent sequence. Fine, by the nth term test, it's a sequence because it goes to the infinity. If you take the limit as xn approaches infinity or n approaches infinity, this is the xk, or you can write in the proper limit k approaches infinity xk plus 1, definitely it goes to the, so that's a divergent. First is the right answer. If you look about the second option, n is equal to 2, then your x1, it is half xk plus 1 over xk. Fine, now you can easily find the limit point. Fine, it is a 1 over x, you can easily find the limit point, so it is a convergent, but we need a fail, so that's a is my right. Look at the next one. Consider the iterative scheme. Initial point is given to you, then the sequence converges. Again, it is my iterative scheme. When it will be convergent? It is convergent to the fixed point. How you can find the fixed point? That is nothing but my limit. So I can start with the limit. So I can take the fixed point is my x. Fine. So that means I can say limit of the xn as n approaches infinity is my L. So definitely if xn converges to the L, then n minus 1 is also converges to L, xn plus 1 also converges to L. So this number is L over 2 plus 3 over L. So this will be L over 2 is 3 over L. So L will be plus root 6 minus root 6. But you can see x naught is my positive, so this number will be cancelled out. So xn converges to the plus root 6. Does not converge, cancel. Converges only, but wrong, because if you take x naught is say 0.5, it is a positive, then it converges to the positive. Converges only for wrong. If you take x naught is my 5, then again it converges to the, converges for any x naught. No, yes, because x naught is my positive, so you can choose any x naught which is a positive number. You may choose 1.5, you may choose 71.3 and so on. So the right option is my C is the correct answer. Again remember, if instead of the x naught as greater than 0, if x naught is given you say minus 3, which is a negative number, then it converges to my minus root 6. Hx is a twice continuously differentiable function with a fixed point. That's the most important thing. Fixed point is given to you as alpha. Then the sequence converges quadratically. That means limit x approaches alpha minus is absolute value over x minus quadratically. This is my find. This is given to you. Fine. This is given to you because it converges. Then what will be the condition? That's again very simple. I can start with this condition. Xn plus 1 is h over x minus alpha, which is a finite number. But if you substitute x as a denominator is a 0, so when it will be the finite? It will be the finite only when h of x is my alpha. Then only it's a 0 by 0 form. So now if I apply the h derivative rule, so it is 2 times x minus alpha, limit x approaches alpha. Then again when it will be the finite, because again you can see when you substitute x alpha in the denominator it's a 0. So when it will be, when h dash of alpha is my 0. Fine. Then again apply the L'Hopital rule, limit x approaches alpha, h double dash over 2. Now when it will be the finite. Fine. So h dash will be 0. H dash will be 0. H dash will be 0. That is the required answer of this problem. That's the first method. There is one more method. That means, now what is that method is, if you have the scheme xn plus 1 is gx, fine, then this equation scheme gx has order say n. What does it mean is, the first derivative will be 0, fine, second derivative will be 0, and so on up to the n minus 1 derivative 0, and nth derivative is my non-zero. Now if you look about this condition here, this is quadratic. That means convergence is my 2. What is the convergence of the 2 meanings? That means h is a g of x is also 0. That means h of x is also 0, and fixed point is alpha. So h of alpha is also 0. H dash of alpha is also 0. H double dash of alpha is my non-zero. Or you can write it directly by using this shortcut tricks. Otherwise you can start with the definition and you can get the required result. Okay, suppose x naught is sufficiently close to the 3. Okay, fine, this is given to you. Then the equation scheme will converge to the fixed point. Again, what does the meaning of the x converges to 3? That means x is equal to 3 is my fixed point. Fine, clear? So firstly you can check about whether 3 is the fixed point or not. So we will see whether 3 minus those option which 3 is not the fixed point, you can discard the option 3 plus 1. So yes, it is satisfied. From this case 3 6, yes, again satisfied. 3 minus 2 satisfied. 9 minus 3 over 2, yes, all are satisfied. So this, none of the option is discarded. Anyhow, we will use the second concept. What is the condition for the convergent? G dash x should be less than 1 at the fixed point. That means at x is equal to 3. So firstly find the value of g dash x. So what is the derivative? 6 minus 3 over x square. So this will be 6 minus 3 over 9, which is not less than 1. Look at the second option. What is the g dash? It will be 1 over 2 times 3 plus 2x into 2. Now at the point of 3, it is 3 plus 6, which is less than 1. Yes, this is the correct answer. Look at the third option. G dash will be minus 3 over x minus 2 square. If you take the absolute value at the point 3, 3 over 1, which is not less than 1. Look at the last option. What is the derivative of this? Xn, which is a 3, which is not less than 1. So the right option is only B is my correct answer. Phi is my 3 times continuously differentiable function. The equation scheme xn plus 1 is phi times xn has the fixed point. So xi is my fixed point. Then order of the convergence is 3. What does it mean? Order is my 3. Again you have the two method. Fine. The first method by using this definition, or second method is you can apply this shortcut tricks. Remember, this is applicable on the G, that is the equation scheme. What is the G in this case? Phi. Fine. Order is 3 means phi, fixed point is alpha, it will be 0. Phi dash of this is 0. Phi double dash of xi will be 0. And phi of triple dash is my non-zero. So phi dash 0, phi double dash 0, correct. Phi dash non-zero, wrong. Phi dash 0, correct. Phi double dash 0, wrong. Both are wrong. So A is my correct answer. If you apply the second method, I can do the second method also for you. So let me clear this one. What is the second method is? Limit x approaches xi, xn, that is phi minus xi over convergence has order 3. Now that means this number is my finite. If you substitute xi, it's a 0 by 0, that means this must be 0. If you take the derivative, it will be my phi dash divided by 3 times x minus, again we need a finite number, but if you take the limit as xi is a 0, so that means phi dash of xi must be 0, then only it's a 0 by 0 form. Phi double dash, again it is a finite only when phi double dash of xi will be 0, and if you take the third derivative, it is a phi double dash over 6, and clearly say it is a finite number provided this is my non-zero. So that's why this is the right answer. Okay, for the fixed point xn plus 1 is g of xk, consider the following statement. If g is my 1 plus 2 over x, the fixed point converges to the 2. Again the same concept, when it will be the convergent. If it is convergent, then it converges to the fixed point, and that fixed point will be my limit. Fine. So we will see whether 2 will satisfy, whether the 2 is a fixed point or not. Yes, satisfied. So once it is a fixed point, if it is converges to a fixed point, then it is convergent for any choice of the x naught. Fine, it is convergent, then it is convergent for any choice. So whatever is the limit is the correct option. The fixed point equation again convergent to the 2. Again we will see whether the 2 is the limit point or not. 2 plus 2, yes, it's a plus minus, but we need a positive number. So 2 is 2, yes, it is also the correct option. So both A and B, P and Q are the correct option. Like and comment and subscribe my YouTube videos. I will upload my next video if I get a good response on these lectures. Okay, consider the fixed point equation. Phi of x is my 3 plus x minus 3 whole cube, where x lies between 2.5 to 3.5. Initial guess is given to my this number, that's a positive. Then the order of the convergence. That means your target is to find this number xn plus 1 minus over xn minus something raised to power p. Your target is to find the p. Fine, but before the target, your target is what is that number, because it's a fixed point, so that number will be my limit point. So is the limit point given? No. Can you find the limit point? Can you find the limit point? Clearly say x is equal to 3 is my limit point, because if you substitute 3, it is a 3 plus, yes, x equal to 3 is the limit point. Also you can see 4 is also the limit point, 4 which is equal to 3 plus 1 cube, but 4 is not belongs to 2.5 comma 3.5. So that means the limit point is my only 3. So once you can get a limit point 3, that means this number is 3, because if limit point, then it the fixed point equation converges to the limit point. Now substitute the value of what is given to you, xn minus 3. So if you substitute at this point, xn minus 3 divided by x minus 3 raised to power p, so it will be 1 over x minus 3 raised to power p minus 3. Then we will get the order of convergence. So that means my target is to find the number which is my finite. Fine, this is your target basically. Now can you find the limit? Again, it's so very simple. What is that? If I take p is equal to 1, it's a finite. P is equal to 1, finite, yes, because p is equal to 1, it is a minus of 2. I can substitute in the upside, it's a 0, it's a finite. When p is equal to 2, again finite. When p is equal to 3, again finite. When p is equal to 4, it is my infinity. So definitely 4 will not be the order of convergence. Now out of these three cases, what is the largest value? Largest value is my 3. So that means 3 is my order of convergence. Always remember, you will get the finite limits. If you get more than finite limits at the different value of p, pick the largest possible limits of the p, value of the p. Okay, the real sequence generated by the iterative scheme. You may consider this question as a real analysis, but you can think about this question as a numerical analysis as well. Convergent, 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 divergent. Again, if it is a iterative scheme, if it is a convergent, then it converges to the fixed point, and that fixed point will be my limit. So I can simply choose limit of x will be my L. Fine. So if I substitute this L, it is L over 2, 1 over L. So that is L over 2 is my 1 over L. So L will be plus minus root 2. One is the positive, one is the negative. Now look at that. Now initial value is not given to you. Convergence to the root 2 for all the values of x naught are minus. That's wrong, because if I choose x naught is my minus 3, then it will converge to the minus root 3, but he said positive root 3. Whenever x naught is my, this number is my positive, fine. When you take x naught is my positive, then it will converge to the plus root 2. Yes. Convergence to the root 2 for all those values which is non-zero. Wrong, because if I take x naught is my minus 0.5, then it converges to the minus root 2, but he said plus root 2. That option is cancelled. It's a divergent. That's wrong, because we get a limit point. Fine, that's a limit point. So once a limit point, that's a fixed point, it's a convergent guarantee. So right answer is B is my right answer. Okay, which of the following is a convergent, divergent, increasing, decreasing? I think it's a very simple. Again, you can see it's a iterative scheme. Fine. So this is my G. What is the G dash? Minus sine xn. What is the value of the G dash? Sine of. Fine. So that means convergent. So this is my wrong option. Now once it's a convergent, we have to check whether it's increasing, decreasing or not. X naught is my 1. What is my x1? If I substitute x1, x naught, that's a cos 0. X naught is my 0. X naught is given to 0. So if it is there, cos 0 is my 1. What is my x2? Cos 1. That is a number which lies between minus 1 to plus 1. So clearly say, when you go from x0 to x1, it is increasing, values are increasing. But when you go from x1 to x0, it's a decreasing. But he said always increasing. Wrong. Always decreasing. Wrong. It is convergent. Definitely it's a even and the odd sequence. So the right answer is C is my correct answer. You can see within a 10 to 15 seconds you can solve this easily. The number of the roots of the equation is equal to. Again, it's a roots are equation. I can say this is my this. I can write this as a fixed point. Fine. Or I can simply think about it from this. Now I think it's easy. I can draw it graphically. This is the graph of the x square. Fine. Can you draw the graph of the cos x? This is the graph of the cos x. Fine. This value is, this is the graph of the cos x. So cos pi by 2 will be 0. So pi by 2 means 3.14 over 2. That's a 1.57. And this is minus 1.57. And this number. How many fixed? So what is that? I think that's everybody understand it. How you can solve? You have to find the number of the fixed point. So one fixed point is this. Second fixed point is this. How many fixed point you have? 2 is the right answer of this problem. Fine. You can see that these are the two solutions in this interval. Minus, this is the minus pi by 2, this is the plus pi by 2, and it intersect at the 2 points. So that means the right answer is 2 is the right answer. Okay, is twice the order of convergence of the secant method. We all know the rate of order of the convergence for secant method is 1.618, and if you do it calculation, you will get A is the right answer. Always remember, the bisection method has the order of convergence 1. Regular falsy method has the rate of convergence 1. Secant method has the rate of convergence 1.618. Equation method, that is a fixed point equation method, has the rate of convergence 1. Newton-Raphson method has the rate of convergence 2. Now look at that. This is GATE 2023. F is a twice differentiable function of the closed interval a comma b. F dash is less than 0, f double dash less than 0. I think it's a simple. I can choose a function whose first derivative and second derivative is less than 0. Fine. That is quite easy. For all x lies between, so what is f dash? Minus 2x. So I can choose any of the x. So I can choose x belongs to 0 comma 2. Fine. That means I have chosen a is my 0, b is my 2. Xi lies in between them. So I can choose xi is 1. Fine. Then the Newton's method will be xk. F will be my 1 minus x square divided by minus 2x. So I can take the LCM. It's a minus minus plus. It's a 2x square plus 1 minus x square over 2x. So that will be, so I can write xn plus 1 will be 1 over 2 x plus 1 over x. Fine. So this complex formula will becomes my this quantity. Xk lies between xi. What is xi? 1. B is my 2. So I can choose any of the xi k. I can say xi k is 1.5. Then which of the following statement is my correct? That's over. Xk plus 1. 3 by 2, that's a 1.5. It's a 2 over 3. So what is the LCM? 9 plus 4, 13. 13 over 12. So if you divide them, it is my 1.08. Now look at that. This number is my 1.08. Xi is my 1. Is it satisfied? Yes. Xk plus 1. Is it xi 1? Is it less than 1? No. Xk plus 1. Xk plus 1 will be 1.08. Xk I have taken as 1.5. Is it satisfied? Yes. Choose eta any number between xi 1, 1.5. Fine. Then f dash is my this. So that will be my minus 2 eta divided by minus 2 xk. Fine. Is it greater than 1? So we can see I can choose any number, say 1.3. This is my eta. So it's a minus 2 will be cancelled out. So it will be my 1.3. Xk is my 1.5. Does it satisfy? No. That option is cancelled. So the correct option is A and C are my correct option of this example. Look at this another one. It's a recent GATE 2024. P1 and P2 are the two fixed points of this scheme. Okay, that's very nice. Fine. No, x and k. No, yes. It is given to you g of xn minus 1 and P1 and P2 are the two fixed points. Then which of the following? I think it's a simple. You can draw it graphically. What is a e raised to power x graph? E raised to power 0, 1. This is the graph. But because of negative 2, the graph will be look like this one. Fine. And it has a two fixed point. So these are my fixed point. This value is my, and this number is my, this number is 0, P1 is less than P2. So this number is my P1, this number is my P2. Fine. Let the sequence is generated by this. Which of the following convergent? Oh, definitely it will be convergent because the fixed point will convergence to the fixed point. Now you have the two fixed point. So it means either it will converge to P1 or it will converge to the P2. Now first point, for any x naught in between P1 and P0, choose either I can choose x naught here or I can choose x naught at here. That's on my choice. So let's say I can firstly choose x naught at this point. Then what is the iteration of this? If this is x naught, can you find the x1? I can find the value on this g. Firstly, this is my g of x. I can substitute this x naught here. I can find the value. This is my x1. Fine. I can find this value on the fixed point. Then I can again find this value. This is x2 and so on. So definitely it will be reaches toward the point this, that is P1. So that's first point satisfied. If I choose a point at here from the 0 to P2, I can find the value this. Go towards the y is equal to x. Then I can find this value. Then I can find this equation corresponding this and so on. Again it will reaches toward the P1. So yes, A option is the correct option. Look at the second, converges to the P2. That's wrong because if I take x naught in between the P1 and P2, it converges to the P1, but it's a P2. Xn converges to P2 if I choose any x naught which is greater than of the P2. If I choose any x naught at this point, fine. Choose pick the point on this curve, then it will move on this, then again on the point, like this is the equation of this form. Fine. If I choose this value, then I can find the point on this line, then again, then definitely it will be divergent because it is very away from the fixed point. So therefore he said converges to P2. That's a wrong option. Now look at this. I can again draw the diagram for this last case. Again the same diagram. This is my x square. Fine. And this is my fixed point. This is my P1. This is my P2. If you choose any point x naught which is less than of P1, that means I can choose this is my x naught. I can find the point on the G. This is my G. Then I can move on this line y is equal to x. This is my point. Again I can find this point on this curve. Again I can move on this. So definitely I will reach at the point of P1. So yes, it will converge to the point P1. So the right answers are A and D are my correct answers of this problem. This is the way you can solve all those PY questions in a very simple manner. I hope you can like, subscribe and comment on this video. We will see the next lecture on this coming week related to the next numerical analysis. Till then you can like, share and comment on videos. Best of luck students. Happy learning.